All right, here we are with the last installment of section 1.4. Again, we are discussing the continuity. And actually, a little more specifically, we have to find the x values at which f is not continuous. And are there any discontinuities that are removable? So we need to discuss the continuity. We specifically need to find the x values where f of x is not continuous. And then we are asked something about, are any of the discontinuities are any of those discontinuities removable? Okay, so we need to throw in there removable and non-removable discontinuities. All right, so we'll actually be seeing the beginning of that here. A discontinuity is removable if it's one of those that you can simplify. So far, the only problem we've actually looked at that would have had these instructions was the one on the previous page. And this is continuous everywhere, so we don't need to worry about removable discontinuities. This is always continuous. There's nothing to talk about any x values of discontinuity because this is always going to be continuous. All right, now over here, this function will have places where it's not continuous. And we do have to know things about functions, like what's not allowed on the bottom, which is 0. So the numbers here that are not allowed in for x, then, numbers that are not in the domain, are x could not equal 1 and x cannot equal -1. These are the x values at which it is not continuous. Okay, so we've actually answered part of the question by saying it is not continuous at x equals 1 or x equals -1. Now, are either of those removable? Okay, once you find out they're removable, you don't get rid of them because it's still a point of discontinuity. Okay.
Rachel Clark, if you're in the building, please come to the office for your volleyball check. Rachel Clark, please come to the main office for your volleyball check. Thank you.
Okay, so the only thing I have to do is decide, is this removable? Are either one of these removable? Okay, what you need to notice is that this function could simplify to x squared over x plus 1 times x minus 1. Okay, now that's not really simplifying, it's just factoring the bottom. Now, nothing actually cancels. So since nothing cancels, nothing is removable. This function doesn't become a simpler problem. That's all we're doing when we simplify to find limits, is we're finding a simpler problem. So since it doesn't simplify, none of them are removable. So this is not, to discuss the continuity, this is not continuous at x equals 1 or x equals -1, and neither, I'm sure I'm spelling that wrong, sorry, neither are removable. Or you could just say not removable. Whereas, take a look at the next problem. You have to realize that this is not going to be continuous where x values are not in the domain. We've talked about this before. X values that are not in the domain are x values that would make the bottom equal to 0. So I factor the bottom. -10 multiplies by -10, adds up to -3, -5, and +2. So x equals 5 and x equals -2 are where it is not continuous. So it is not continuous at x equals 5 and x equals -2. That is discussing the discontinuity. Not continuous at those two values. All right, so now if any of those cancel, then that one is removable. So notice the parenthesis that has the x plus 2 would cancel with the x plus 2 on the top. So this one, this discontinuity is removable. So x equals -2 is a removable discontinuity. Okay, so I'm modeling how you do and show your problems. You first find where it's not continuous and state both of those. If in the next step you can simplify one of those parts, then that becomes a removable one. You don't finish the whole simplifying before you name where it's not continuous. All right, let's take a look at a couple more. This problem right here, if I want to discuss the continuity, bells and whistles should go off after you look at this for a moment, and you should recognize, hey, it's that function Mrs. Kern talked about earlier. This is actually always the function, -1 where x is less than a, which is 2, and +1 where x is greater than 2, and therefore this is not continuous at x equals 2, and it is not at all removable. You can't simplify this into, you can't make it, you can't, it's not going to work out. It doesn't work. This doesn't simplify. This is as simplified as it ever gets. All right, so now number 46, discuss the continuity of this, naming places where the function is not continuous and if any of them are removable. All right, so this is a piecewise function. All I need to know, this is a line. This is going to be continuous everywhere. Doesn't matter what this says. This would be continuous everywhere. This is a parabola. This is going to be continuous everywhere. The question is, do these two match up? Does this line, whatever it might look like, match up with that parabola at 1? So all I have to do is put 1 into both of these and see if the y values are the same. If they are, it's continuous everywhere. If they're not the same, then it's not continuous at 1. Very simple. I can't fix this. So I put 1 in for x here, so -2 times 1 plus 3 is 1. I put 1 in here, 1 squared is 1, so this is continuous everywhere. That's it. All right, we're about done. I picked out some fun ones. All right, so number 49. What does this mean? The absolute value of x is less than 1. All right, so what does this mean? This is actually saying where the absolute value of x is less than 1. I don't know if you remember absolute value inequalities. Less than means and this would be where x is less than 1 and x is greater than -1. So that's what this means. So you're graphing the tangent of pi over 4x everywhere x is less than 1. So here's 1. And everywhere x, where it's less than 1 and greater than -1. So basically the tangent of pi over 4x is right in this middle section. Okay, the graph of tangent of pi over 4x is here. Now the period length of tangent of pi over 4x, you take the number in front of the x, pi over 4, and divide it by 2 pi. Actually just pi in the case of tangent, because the period length of tangent is pi. If I divide that by pi, multiply by 1 over pi, and so the period length of this is 1/4. All right, so you've basically got a whole bunch of little tangent graphs in here. All right, so you've got like the whole tangent graph, like the little swoopy things within. No, I have this backwards. I knew that was going to be wrong. Okay, the period length is pi over b. Okay. So pi divided by pi over 4, which gives me 4. I thought that 1/4 was wrong. So the period length is 4. Okay, so this is only going to give us like half a period of the tangent function in here. So I don't know, it's probably going to, it's going to be some swoopy thing probably like that in the middle. All right, and then otherwise after that, for this, where the absolute value of x is greater than 1, which actually means x is greater than or equal to 1, or x is less than or equal to -1. So everywhere up here and up here we graph the line y equals x, which just means basically at 1 it's at 1, it's going to look like this from here on out. So now the the cool thing, maybe the tangent function here, and I'm just going to graph this on my graphing calculator to show you, which is really what you should do. It's kind of a waste of time if you are struggling with. So I'm going to type in the tangent of pi x divided by 4, and I'm going to hit graph, see what happens. Okay, so here's what the graph looks like right in there. Oh, look at that. It is the other way than what I have it. And so if I go here and I hit the trace button at the x value of about -1, it's at -1. So look at that. That's what it looks like. Tell me about the continuity of that graph. It's continuous everywhere. So sometimes we use a combination of stuff. Okay, the hard part was understanding these things. I think I picked out like the hardest one on here. So, all right, couple more. All right, now this one, discuss the continuity of this. At what x values is it not continuous or any removable? This is easy. This is not continuous. Why? It's a step function. And it's not continuous at all integer values of x. How did I know that? I learned Algebra 2 that this is a step function, and step functions are not continuous. And I'm just telling you to memorize that this is not continuous at integer values of x. Now that's not always the case because there'll be like 1/2 and 1/3, but we really rarely have to deal with those. All right? So, all right, I'm just going to throw 2 more at you. F of x is the cosecant of 2x. Now, the cosecant function we know is not continuous, but we would have to name like where it's not continuous. So all I'm going to do is I'm just going to sketch a graph. But you're like, oh, how do you put cosecant into your function? Well, cosecant is 1 over the sine of 2x. So I can graph that. So if I take 1 divided by the sine of 2x, and I hit graph that, that's actually my cosecant graph. And I'm going to zoom, once it's graphed, I'm going to zoom trig this. Zoom and then 7 is a trig. And what it does then is it just makes all the marks into like pi's and stuff and pi over 4s. So this is not continuous at x equals, I'm going to hit my trace button on here, and so it's going to hit these, and it's following, you know, I'm thinking like at pi over 2, so like around 1.57, that's about pi over 2. So it's not continuous at all, so like it'd be pi over 2 and pi, excuse me. Let's just see where this other one, is this about at 3.14 where it jumps over? Yep, okay, so it's not continuous at x equals pi over 2, comma pi. So basically it's pi over 2n and pi n. That's where it's not continuous. All right, we're going to skip 52, the tangent of x, and call her good. So trig ones usually just mess you up. Just sketch a graph, look up on the internet about where tangent and cotangent and all that stuff is not defined. You should have had bunches of notes on that when you took pre-calc and kept them. So, all right, I would expect you to have number 14 done, or mostly done when you come to class Friday.